Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to provide an opportunity to learn about AI and explore how to benefit from this remarkable technology. The entire series is available to view at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation. Every AI system you've ever used has one thing in common. It learned from examples. It wasn't handed a rulebook. It was shown data, lots of it, and it picked up patterns from what it saw. Those many examples are called training data, and it basically determines almost everything an AI gets right and everything it gets wrong. In this presentation, we'll talk about training data and why it matters more than most people realize. So where does AI knowledge come from? We tend to picture AI as a giant set of instructions. If this, then that. But modern AI doesn't work that way. Nobody sat down and typed in every rule for recognizing a cat or writing a sentence. AI doesn't follow rules someone typed in. It learns from examples. The AI system has shown thousands or millions of examples, and it figures out the patterns on its own. Those examples are what we call the training data. Change them, and you completely change what the AI becomes. It's like planting a seed. What grows depends entirely on what you feed it. So to answer the question, what is training data? Let's define it plainly. Training data is the collection of examples in AI studies in order to learn how to do its job. Think of it like a student. A student doesn't memorize one rule and suddenly understand math. They work through hundreds of practice problems until the patterns click. An AI does the same thing. It works through enormous numbers of examples until it can handle problems it's never seen before. The examples are the lessons. The model is the student. The model, simply put, learns in the same way a student would, through thousands of worked examples, not just a single rule. What does training data look like? Well, training data can be almost any kind of recorded information. For a chatbot, it's mostly text, from books, articles, and websites. For a tool that recognizes objects, it's images. For a voice assistant, it's audio, speech, and recordings. For a coding helper, it's code. The common thread is simple. Whatever you want the AI to get good at, you show it many, many examples of that thing. The type of data you choose shapes the kind of skill the model ends up with. So how does raw data actually turn into something useful? From examples to patterns, there are roughly 3 steps. First, the AI model sees the examples. It reads through millions of datasets. Second, it finds patterns. It notices which things tend to show up together. For example, the word salt often appears near the word pepper. A photo of a beach often shows sand and water. Third, it makes predictions. It uses those learned patterns to handle brand new situations. That's the whole loop. Examples in, patterns learned, predictions out. Now here's why training data matters so much. There's an old saying in computing, garbage in equals garbage out. It applies perfectly to AI. A model can only ever be as good as the examples and data it learned from. When it comes to data, quality matters far more than size. If you feed an AI model errors, gaps, or outdated facts, it won't know any better. It'll repeat those mistakes right back to you, often with total confidence. A model can only be as good as what it learns from. The data isn't just fuel for the AI. It's the source of everything the AI believes to be true. Think of it this way: if you teach a student from a textbook that is full of errors and wrong information, the student will confidently give wrong answers based on what they learned and never even realize that it was wrong. There is also a hidden risk with training data, and it's one of the most important concerns in working with AI. When there is bias in the training data, naturally, bias in will result in bias out. If the examples lean one way, the model learns that leaning that way is simply the truth. And here's what makes it sneaky. Nobody really typed the bias in. No one wrote a rule for it. It just seeped in quietly from the data itself. That's exactly why it's so easy to miss and so easy to trust by mistake. The AI sounds neutral and confident, even when it's just echoing a slant baked into its training data examples. Think of it this way. If every cooking example you ever saw used only one type of cuisine, you'd assume that's how everyone cooks. The issue of bias isn't theoretical. It shows up in real life, in tools that people actually rely on. Take hiring tools, for example. An AI trained on a company's past hires can quietly copy whoever was favored in the past and keep overlooking other candidates. Or consider health tools, where a model trained mostly on one group of patients can end up working poorly for others it didn't learn enough about. In both these cases, the AI isn't broken. It's faithfully reflecting the data it was given, which is exactly the problem. It's acting based on an inherent bias from its training data. Let's pause and reflect on the sheer scale of training data, because it's hard to picture. A large language model may train on trillions of words. That's more text than a single person could read in thousands of lifetimes. That massive scale is genuinely powerful. It's what lets a model pick up subtle patterns a human never could. But scale is not a fix for quality. More data doesn't cancel out bad or biased data, it can just spread the same problems further and faster. Let's review our 3 takeaways from this presentation. Number 1, training data is made up of examples, not rules. Training data is the set of examples an AI learns from, not a list of instructions someone wrote. Number 2, data quality shapes output. Bad or outdated data leads to confident mistakes. And number 3, data may sometimes carry bias. Whatever leans in the data will lean in the AI's output. Keep in mind these 3 takeaways, and they will help you in gaining a better understanding of training data and the potential limitations of AI. Thank you for watching. In our next video, we'll be taking a look at AI hallucinations, why they happen, and how to detect them. If you wish to view the next video, simply click on the AIPTD.org URL below, and it will take you to the entire AI for Everyone instructional video library